In 1.14, we're considering infinite limits and vertical asymptotes. Okay, so I'm going to go ahead and sketch a graph with the vertical asymptote at x equals a. I'm making up a point. Okay, this is my vertical asymptote. Okay, I'm going to draw a made-up graph. Maybe it's going like this. Maybe it's going like this. So in terms of limits, as x is approaching a, it could be going down to negative infinity, or the y values could be approaching positive infinity. So limit as x approaches a of f of x should be equally, it could equal to positive infinity or negative infinity, or sometimes we just say it does not exist because it's infinite. Okay, now we're going to find some asymptotes and consider the behavior. Okay, look at example 1. It says given f of x equals x squared plus 2x minus 8 over x squared plus x minus 12. I'm of course going to factor this so I can see what's happening here. Okay, the x plus 4's cancel, which means there's a hole there, but they're not asking me about the hole, so I'm not going to worry about that. Okay, they're asking me about the vertical asymptote. So to find the vertical asymptote, I'm going to look at the denominator, set it equal to 0, and solve for x. So if x minus 3 equals 0, well, it must be true that x is equal to 3. Okay, now I'm going to find the limit as x approaches 3 from the negative side of f of x. Okay, now because there's a vertical asymptote at 3, I'm expecting my answer to either be positive infinity or negative infinity. Now, how am I going to figure out what happens on the negative side? Okay, so one way to do it is if I approach from the left side, I'm just a little bit lower than 3. So I'm going to consider what happens at a number just a little bit lower than 3, maybe 2.999. And again, I know this is going to be positive or negative infinity, so this is just helping me get like a clue. Okay, if I do 2.999 minus 2 over 2.999 minus 3, what am I going to have? 0.999 divided by negative 0.001. Okay, so if I have some number divided by a negative 0, I'm going to end up with a negative infinity. So as x approaches 3 from the negative side of f of x, y is approaching negative infinity. Now let's consider it from the positive side. So from the positive side, I'm going to think of a number that is a little bit more positive than 3. So maybe 3.001. And I'm plugging it in the simplified expression because it will give me undefined for the original. Okay, I know it's either going to be positive infinity or negative infinity, so that's really all I care about. So I'm going to have 1.001 over 0.001, which is like positive 1 divided by positive 0, which is going to give me positive infinity. Okay, so on the right side, the graph of the asymptote, the graph is going up towards positive infinity. On the left side of the asymptote, it's going down to negative infinity. Let's consider a couple other ones. Okay, let's look at 2. Okay, it's only, for example 2, for a, it's asking that the limit as x approaches 3 from the positive side of 1 minus x over x minus 3. And again, it looks like there's an asymptote at 3, so it's either going to be positive infinity or negative infinity. So from the positive side, let's consider something just a little bit higher than 3. So if I do 1 minus 3.0001 over 3.0001 minus 3, I'm going to get negative 2 point something, and I don't even really care about the rest of it. I'm divided by positive 0.0001. So negative 2 divided by positive 0 is going to give me negative infinity, which tells me that the limit as x approaches 3 from the positive side is going to be negative infinity. Okay, let's look at B. It says the limit as x approaches 1 of this expression right here. Okay, I'm going to factor it because it never hurts unless I can already tell what's going to happen. Okay, so that's going to make this the limit as x approaches 1 of x minus 3 over x minus 1 times x minus 1. So x minus 1 squared. Okay, now eventually you'll probably do this in your head, but it's telling me x approaches 1. It's not telling me from the negative side or the positive side, and I can tell there's an vertical asymptote x equals 1, so it's going to be positive or negative infinity. So even though it doesn't tell me to, I need to consider it from the positive side and consider it from the negative side. So if I come from the negative side, I'm going to have 0.999, something like that, minus 3 over 0.999 minus 1 squared. Okay, 0.9999 minus 3, negative 2 point something. And then in the denominator, I have negative 0.001 squared. Okay, which is going to give me a negative 2 point something. Now, if I do negative 0.001 and I square it, I'm going to get 0.000, I don't know how many zeros there are. Actually, there's 4. 1. So negative 2 divided by positive 0 is going to give me negative infinity. Okay, now let me check it from the positive side so I can see if they converge to the same thing or if it's going to be doesn't exist. From the positive side, let's consider 1.001 over 1.001 minus 1 squared, which is negative 1.999, which is almost negative 2, over 0.001, and I square it, which is negative 1.999 over 0 point a bunch of zeros, 1. So I have a negative almost 2 divided by a positive 0, which is going to give me a negative infinity, which actually matches the other side. Okay, so since the limit as x approaches 1 from the negative is negative infinity, and the limit as x approaches 1 from the positive is also negative infinity, I can conclude that the limit as x approaches 1 of the original function was negative infinity. Okay, if one of these had been positive infinity and one of these had been negative infinity, I would have concluded that the limit does not exist. Okay, let's consider one last one. Okay, limit as x approaches negative 5 of x over x plus 5. I can tell that at x equals negative 5, there's going to be a vertical asymptote. So again, I'm expecting the answer to be positive infinity or negative infinity. Since it doesn't tell me positive or negative, I need to consider both directions. So if I do negative 5 from the negative, let's see, I'm going to have negative 5.0001 over negative 5.001 plus negative 5. So negative 5 point something over, and that's a positive 5, just kidding. So I have kind of like a negative 5 divided by negative 0, which is going to give me a positive infinity. Okay, now let me consider it approaching negative 5 from the positive side. So negative 4.999. Okay, let's see. I'm going to have negative 5 divided by like a positive 0, which is going to give me negative infinity. Since these don't match, then in this case, the limit does not exist. Technically, in part B, it also didn't exist, but because I could give a good description for it, I still said that I still indicated as negative infinity because that was more informative than does not exist.